Now, instead of 1, I'll write I. Instead of small x, I'll write capital X. This is a matrix. Now, I take this matrix and invert it. Now, the question is, can I write this as identity minus x plus x squared by 2 factorial minus x cubed by 3 factorial plus and so on? Question. What do you think is the answer? Hmm? What do you think is the answer? Yes. What do you think is the answer? Guess. Huh? It should be true or not true? True, right? Why? Huh? Okay, so first of all, you should understand why this is true, right? What is it that you are doing here? You are essentially saying, what is this equal to means? It means, you look at, subtract the left hand side. What is the left hand side? Summation k equal to 0 to n minus 1 power k x power k over k factorial, right? This is a partial sum on the right hand. Do you agree with this? Right? You look at the absolute difference of this. This is the error if you use only n terms. Now you are saying limit n tending to infinity is 0. This is the meaning of this, right? It's basically series, and this is how you deal with series, right? That's why you start with limit, and then if you have a series, I can think of series as a sequence, right? And the limit of it. Okay. Now, what does this mean here, right? So this also means I have to look at I minus x whole inverse minus, this is the meaning, right? Minus 1 power k x power k over k factorial. This is the difference. But can I take absolute value here? Can I take absolute value, or what should I take? Some type of norm, right? Which type of norm should I pick? Well, does it matter which norm I pick? Equivalence of norm, right? So you take any norm, your favorite. Okay, so I'll call it as your favorite norm, and limit n tending to infinity. This is 0. This is the meaning of I minus x whole inverse in matrix, right? So this is how this is the actual meaning. Okay, it turns out that this is true. Okay, I can so go back to your calculus course. You look at how you wrote this. You do exactly same things. Replace small x by capital X, 1 by identity, and mod difference by norm difference. Everything will go through. Okay, you can essentially write a book, right? If you have a book on series, you can essentially write a book on matrix series, whatever. Okay. Okay. So clear? So remember this, I minus x, if norm of x is less than 1, I minus x is invertible, and I minus x whole inverse is given by this series. So can I write log of 1 plus x? Well, it doesn't make sense here, but okay, let's look at another thing. Let a, okay, let me directly write this. I'll write this as s plus plus n. Okay, what is the meaning of this? It's s for symmetric, plus plus for positive definite, n for the dimension, right? Then I can take exponential of 80. What is this? Can somebody tell me? Huh? Can somebody tell me what is this? How do you write this? What is e power ax? E power ax. How do you write this? 1 plus? Huh? How do you write this? 1 plus ax plus a square x square by 2 factorial plus a cube x cube by 3 factorial plus and so on, right? So can I write this exactly like that? K equal to 0 to infinity. I'll write it like this: a power k over k factorial times t power k. So question: Well, in fact, in this case, I can actually prove this. Okay, so it turns out that I can actually not prove. Okay, let's see what are the things one can do. Okay, so now let's look at the left hand side. Okay, so let's see what we can do here. A power k over k factorial t power. Well, I think this t is a nonsense parameter. I'll just knock it off. Okay, it will keep appearing everywhere. I mean, you can always redefine a as ta.